Today we'll see the design of common drain amplifier. For that, open terminal, press CSH to source the C shell. To source the cadence tool or cadence license, type source space /home /install /cshrc. After that, you have to source the Virtuoso tool. To source the Virtuoso tool, type Virtuoso space ampersand. So now your Virtuoso tool will be sourced. Okay. So after sourcing Virtuoso tool, open cell view. For that, go to file, new cell view. Create the cell view in the library which you have already created. The library is demo. So you give some name. So I will give the name as common drain 1. I'll give the name as common drain 1. After pressing OK, this new cell view window will open. So after getting this new cell view window, place NMOS and PMOS. As this is a common drain amplifier, both the devices what we are using, it is pull up and pull down, both are NMOS. Okay. So select both NMOS devices. To select NMOS, go to create instance, browse. In library, select GPDK180. In cell, select NMOS. NMOS. In view, select symbol. After selecting these three, you will get this add instance window for NMOS. In that, select length as 1 micrometer and width as 50 micrometer. Change length to 1 micrometer, width as 50 micrometer. So micrometer you cannot type in the keyboard, type it as U, 1U and 50U. After that, press hide. Place this as a pull-up transistor or top transistor. Similarly, take another transistor. To take that, go to create instance, browse, GPDK180. Cell is NMOS. In view, you have to select symbol. Press close. Length you select it as 1 micrometer, that is 1U, and width is 20U. Press hide. Place at the bottom. So after placing both the devices, connect both the devices through wire. You can select wire here, or shortcut for wire is W. Connect both the devices through wire. Short source and drain, and source of this transistor you connect with the wire for further connection. This I will connect to V out pin, so I have extended this wire. This I will connect to VDD, so I have extended and kept the wire. This I will connect to V bias pin, sorry, V in pin. I have extended a wire. This I will connect to V bias pin, so I have extended a wire. Now take each and every pin and make the pin connections. To take the pin, select P. In keyboard you type P. You will get this create pin option. First pin you take it as VDD and connect at the top here. Next pin, again type P. Direction is input, so take it as V in pin and connect to this top NMOS. Next again type P. Type as V bias pin. V bias pin. Connect to the bottom transistor. Next again type P and type it as ground, and direction is input. For all the 4 pins, the direction is input. Okay. Press hide and place here. Last pin is your V out pin. For that, press P. Give name as V out. Press hide and connect. So press P. Give name as V out and change the direction to output. Because it is a Vout pin, its direction should be output. Select it as output and press hide and connect here. And last connection which is left out is substrate connection. So here substrate of NMOS is always connected to most negative voltage. So most negative voltage here is your VSS pin. Sorry, I have named it as ground pin. So I will name it as VSS pin. This is VSS pin. So most negative voltage is VSS. So connect the substrate of NMOS to most negative voltage. Again, this substrate of this NMOS connect to most negative voltage, that is VSS. Okay. So now this is called as common drain amplifier here, because this is a top transistor is the main transistor. Bottom transistor is acting as a resistor. Instead of connecting a resistor, we cannot use a resistor easily in IC fabrication. So if you want to use as a resistor, then the length of polysilicon we can use as a resistor, but it will be having huge length. So polysilicon using as resistor will take more area, more length of IC. So we cannot connect polysilicon directly as resistor because as it takes more length. So what we'll do, we'll use transistor itself as resistor. So bottom transistor is going to implement as resistor. Top transistor is used to implement the amplifier. Okay. So now top transistor we have connected V in to the gate and V out we are taking from the source. This drain is common between V in and V out. For top transistor, V in we have given at the gate, V out we have taken at the source. Drain is common between input and output. So for this reason, it is called as common drain amplifier. Okay. So save this, do check and save. After this, create a symbol for this. First, drawing the schematic. Second step is creating a symbol for this. So to create a symbol, go to create cell view from cell view. After that, press OK. It is asking in symbol wherever what should be your pin location, where you want your pin location to be. Okay. So I will select VDD should be at the top. So I will remove VDD and I will paste it as a top pin. Okay. So next I want VSS at the bottom. So I will remove that. I will press Ctrl X and I will paste it as a bottom pin. Okay. So in the symbol you will get in the same order how you have created here. Your V bias and V in will be the left pin, V out will be the right pin, VDD will be the top pin, and VSS will be the bottom pin. So press OK. You can see the same order here. V bias and V in are the left pin, VDD is the top pin, VSS is the bottom pin, and V out is the right pin. After that, creating a symbol, you again check and save it. This is the option for check and save. Do check and save. If nothing is popping out, then there is no errors. And even in Virtuoso window, I have told that you can cross verify. That is, cross view check completed with no errors. Demo common drain one symbol saved. So last two lines you can see and you can verify that whether there is any error or not. Okay. After this, after getting a symbol, you can minimize this schematic window and open the, now we have to create the test circuit. Now we have to create the test circuit. To create the test circuit, go to File, New, Cell View, have to create another cell view. Give name as common drain, previous name, that is common drain. What name you add, the same name, underscore test. You can give any name. To identify it is a test circuit of your common drain, I have given it as common drain underscore test and press OK. So after this, get the symbol which you have already saved in your library. To get the symbol, go to create, instance, browse. The library was demo library, right? In demo library only I have saved. The name you given it as common drain 1. Take the symbol. In view, you select it as symbol. Press close. And in an add instance window, press hide. You will get the symbol of common drain. Place here. Now you have to connect V bias, V in, VDD, VSS with appropriate voltages. Okay. First we'll start connecting with your V in. V in, we will connect a sinusoidal voltage. Okay. So to create a to connect a sinusoidal voltage, again go to create, instance, browse. All the voltages you will get in analog library window, because all, see, when you want your NMOS and PMOS, you will select from GPDK 180. When you want the symbol, you will select from your library, and all the voltages and ground you will select from analog library window. Select analog library. First select V sign and symbol. View should be the symbol. Press close. After that, you give AC magnitude as 5 milli. Next, you give your frequency, right? Frequency as 1 kilohertz. We just type 1K, and amplitude as 5 milli. So you should give these three things for your V sign voltage. That is, AC magnitude is 5 milli, amplitude is 5 millivolts, and frequency is 1 kilohertz. After that, press hide. Place straight to your V in pin of the symbol, because you can make the connection later. Next, for V bias, we will connect a DC voltage of minus 1.8 volts. For V bias, we'll connect a DC voltage of minus 1.8 volts, because you can see here from your transistor, this bottom transistor only it is used to implement a resistor, which is going to pull a constant DC current. Because of that, for V bias, we'll connect a constant DC voltage of minus 1.8 volts. So for that, go to create, instance, browse, analog library. So DC voltage name in Virtuoso is VDC. Select symbol, press close. DC voltage here, how much you want? It is minus 1.8 volts. You type that and press hide, and place this straight to the pin of your V bias, so that you can make the easy connection. So next you have to connect for your VDD. For VDD also you will connect a DC voltage of 2.5 volts. Again go to create, instance, browse, analog library. In cell you select VDC again, because the name for DC voltage is VDC, and view you should select symbol, and DC voltage value you give it as 2.5 volts, and you place in such a way that plus symbol is towards VDD pin. You can rotate this voltages or any symbol you have by pressing R. If you press R, that is the option for rotate. That is the keyboard option what you have for rotate. Okay, any symbol which you have taken, that will be rotated. So you have placed 2.5 volts straight to VDD, so you can make connection later. Next is VSS. For VSS, again you connect a DC voltage of minus 2.5 volts. Again for that, go to create. In library, select analog library. In cell, you select VDC. In view, you select symbol. Type DC voltage as minus 2.5 volts, because for VSS you have to connect minus 2.5. Press hide and place here and press escape. So this DC voltage will go. Now make all the connections. Okay. Take a wire, connect this VDD pin to the positive terminal of this VDC. Connected this pin, that is VSS pin to positive terminal of this DC voltage. Connect this V bias pin to positive terminal of this DC voltage. Connect this V in pin to positive terminal of V sign voltage, and negative terminal you connect a wire and extend it for ground connection. What I have done, negative terminal and V out terminal I have extended. For negative terminal of all voltage sources, I will connect a ground pin, and for V out I will connect a V out pin. So now we'll connect all the ground pins to negative terminal of voltage sources. For that, go to create instance, browse library, you select analog library. In cell you select ground, GND. In view you select symbol, press close. Add instance window, you press hide because you doesn't have any values to give for ground, and connect to the extended wires of your negative terminals. This connection you have done already. Next, last connection is connect a pin to V out terminal. So you have V out here, right? Connect pin to that. To get a pin, type P. Pin name is V out. Direction is output. Press hide and connect a pin here. Now this completes your test circuit of common drain amplifier. After that, press on check and save, and in Virtuoso window, this first window which was opened, in that you can see that schematic check completed with no errors, demo of common drain underscore test saved. You can see last two lines. You have no errors and it has been saved. You have a message like that. So after seeing this, again go back to the test circuit. So now launch ADEL window for simulation purpose. So ADEL stands for Analog Design Environmental Window. Launch that. Launch ADEL. So now this ADEL window will open. So for common drain, you have to perform 3 tests. For any amplifiers, you have to perform 3 tests. One is transient test, another one is DC response, third is AC response. So to perform all the 3 tests, go to analysis, choose. First is analysis, it is on transient only. The red mark is on transient. So it is asking for stop time. See the frequency you have given 1 kilohertz. If you convert into time, it will be 1 right? It will be 1 millisecond. So you will get 1 cycle in 1 millisecond. So if you want 5 cycles, then give stop time as 5 milli. If you want 10 cycles, give stop time as 10 milli. So any time you can give based on how many cycles you want in the simulation window. After that, give accuracy as moderate and press apply. So you have selected specifications for your transient response. Next, DC response. Click on Save DC operating point. Next, click on component parameter. I have told you why we want to do this. Select on select component. Select on V in. That is, select on this V sign. So what you have to do again, I will tell you. Select on select component. Select on this V sign. You will get the select component parameter window. In that, select first option, that is DC, VDC, DC voltage. So what you are doing, the V sign what you have, that you will convert to the DC voltage. Then you will sweep from minus 2.5 volts to plus 2.5 DC voltage. So now you have to remove your sinusoidal voltage and you have to connect your DC voltage and you have to sweep. That is a long procedure. Instead of doing that like that, your simulation tool has given this option. You select the component, make this as DC component and sweep from minus 2.5 volts to plus 2.5 volts. What you're doing, your V out, you're making it as DC voltage and you're sweeping from minus 2.5 to plus 2.5. So to do that, you're following this procedure. After that, you press apply. Next, last analysis is your AC analysis. In AC analysis, what you will do, you will plot your gain versus frequency. So sweep variable is frequency. Sweep range it is asking. So you sweep from 100 hertz to 1 gigahertz. So you give 100 to 1 giga. Automatic is logarithmic, that is sweep type is logarithmic. You will use logarithmic scale. And points per decade is 20. So in last video, I have told you what is the meaning of points per decade. Okay. So you select, so it will for every 10 frequency, that is every 10 times increase in frequency, okay, it will do 20 simulations. Okay, 20 times it will check your gain versus frequency. It will check your gain 20 times for every 10 times increase in frequency. So for that, that is called as point per decade. After that, press OK. Again, go back to this ADL window, which is already minimized. Go back to that. So you can see at the left, right hand side, you have selected transient response, DC response, and AC response. All the three have already selected. Next, go to output, to be plotted, select on design. Go to output, to be plotted, select on design. So this again test circuit will open. In this, select input wire and output wire. That is wire which is connected to V in pin and wire which is connected to V out pin. Select input wire and output wire. Both should be selected. When both are selected, in ADL window at the outputs, you can see net to 7 means it is your input wire. V out means it is your output wire. Both has been selected. And both, whatever the signal on that wires, that will be plotted. Both has been ticked means both will be plotted. And press on the run button to plot both the signals. Right click. So you select on this, you can split the windows, you can see the waveforms. Click the split option, you can see the waveforms. So I will make little bit thicker. Okay, you can see the waveforms. Now if you measure the amplitude, peak to peak amplitude, so it should be almost equal to 1. The gain should be equal to almost 1. So this is a plot of your V out versus frequency. So your V out is, you're getting total V out as almost 4.2 millivolts. You can see here, right? Till the frequency of almost 141 megahertz, your output is constant and you are getting 4.23 volts, millivolts. So you have applied input as 5 volts, right? You have applied input as 5 volts, but you're getting output as 4.23 millivolts. If you take the ratio of output by input, almost it is equal to 1. We'll get 0.9 something, almost it is equal to 1. So for your common drain amplifier, you should get gain almost equal to 1. That those equations you will study in next year or next sem in microelectronics. Okay, this is a DC response. As your input is increasing, your output is also increasing because it is a non-inverting amplifier. In common source, you have seen that when your input was increasing, your output start decreasing because it was a inverting amplifier. In DC response of this common drain amplifier, you can see that as input is increasing, your output is also increasing because it is a non-inverting amplifier. The meaning is, for positive peak, you're also getting output as positive peak. For input as negative peak, you're also getting output as negative peak. So for this reason, your common drain amplifier is a non-inverting amplifier. Okay. So you can calculate this peak to peak voltage by placing the marker cursor, or you can get V out here only. If you keep your cursor here, if you keep your cursor here, you can see that you can see the maximum V out voltage. This is a plot of frequency versus voltage, your AC response. Maximum voltage what you're getting is 4.23 volts. So that is a maximum voltage. But what you applied here is 5 milli, right? In your test circuit, you applied a voltage of input as 5 milli. You calculate V out by V in, you will get almost 0.9 or 0.91 or 0.912. So it's almost equal to 1. So this is the characteristics of your common drain amplifier. So you can also go to your frequency, that is phase plot, magnitude and phase plot. For magnitude and phase plot, go to results, direct plot, select AC magnitude and phase. You will get select AC magnitude and phase. Select output wire and input wire, and again go to ADEL window back. Select on run button. Results direct plot. Okay, to get your gain and phase plot, go to results, direct plot, gain and phase, select on gain and phase, click on output wire and input wire. So automatically you will get gain and phase plot. Split this. So first you are getting is phase plot. So you can say that. So I will make this as extra thick. Okay. It has stuck 1 minute. Okay. So you can see here the phase is constant and gain what you're getting is minus 1.44 dB. Again what you get, that is 0.9 something, right? So if you convert in dB, the gain what you're getting is 0.144 dB. So if you go 3 dB down, that is minus 1.44 minus 3 dB. If you go 3 dB down, the corresponding frequency what you're getting is your 3 dB frequency. See, the tool has been struck, so I'm not able to show this, only I can explain it. So if you go 3 dB down, that is minus 1.44 minus 3 dB. So it is minus 4.44. So if you go 3 dB down, at that time, what frequency you are getting is your 3 dB frequency. Okay. So your phase, so it is, your phase is almost zero, right? It is little bit below than 0, that is almost 0, it is almost equal to 0.2. So phase is almost 0, that is your input and output both are in phase till some frequency. After that, input and output has some phase difference. So that is what you can see here, right? Your phase difference is almost 0, it is near to 0.2, so it is almost 0. So you can see here also from this window, both are in. Okay, that is not opening it, the tool has been struck. Okay, so this is what about your simulation of common drain amplifier. So it is, you are almost getting gain as 1 and your input and output waveforms both are in phase. Okay, next we'll see the layout in next video. Thank you.